Hello students! So this video here is a continuation from our first video, factoring by grouping. In that first video we talked about what it means to actually group, or what grouping refers to. We talked about also how to even know or how to determine whether or not you can factor by grouping. And we also looked at just a very simple example of how to factor by grouping. In this video, we're going to continue with that, and we're going to look at how to factor quadratics, how to factor quadratic trinomials by grouping. So let's go ahead on and jump into an example. Here we see a quadratic trinomial where the a value is not 1. The a value is greater than 1. Remember, folks, that we can identify what a, b, and c are in a quadratic that's in standard form, because the standard form for a quadratic is ax squared plus bx plus c. So in this particular form, if we identify those three parts, a is the leading coefficient, 3. B is that coefficient in front of the, or the coefficient with the linear term. That's 10. And C is our constant term here, which is negative 32. Alright, so if we know those three parts, then we can go ahead on and start with factoring by grouping. So in order to factor by grouping, what we mentioned in our last video was that the expression had to be written with 4 terms. Okay, so you may be thinking, Mr. Starkey, this only has 3 terms. This one here is only a trinomial. What are you talking about? How are we supposed to factor by grouping? This is not written with 4 terms. It's a trinomial, Mr. Starkey. So that's a fair point that you're making. But it is possible for us to rewrite this trinomial, this quadratic trinomial, as a polynomial with 4 terms. And so we're going to show you just how to do that. So let's look at the steps for rewriting this trinomial with 4 terms. So the first thing that we want to do is multiply a times c. So we've already identified your a, b, and c, and so what we need to do is multiply a times c. Alright, so when we multiply a times c, that is us multiplying 3 times negative 32, which is negative 96. Alright, so since we know that, the next step is to find 2 factors of that product. In other words, find 2 factors of negative 96 that are going to add to give you b. So we're talking about 2 factors of negative 96 that will add to give you 10. So 2 factors of the product, a times c, that add to give you b. And so I don't know if you guys want to do that little thing here, just as a little visual. Not that you have to do that in particular. And then some folks may actually want to list out certain factors of negative 96. So when we look at factors of negative 96, and as of right now, I'm just going to write the numbers, the absolute value of the numbers, and we'll consider the signs after we have the numbers written. 1 times 96, 2 times 48, 3 times 32, 4 times 24, 6 times 16, and 8 times 12. These are the factors of the factors of 96. So we're trying to find 2 factors of negative 96. So they have to multiply to give you negative 96, but they have to add to give you 10. So if we just kind of look at some of these, remember, since negative 96 is a negative number, one of the factors in the pairs, or in the pair that we choose, is going to have to be negative, which means that we need to consider the difference of the pair of factors. So the difference between 1 and 96 is 95. The difference between this second set of factors, 2 and 48, the difference there is 46. The difference between 3 and 32 is 29. The difference between 4 and 24 is 20. The difference between 6 and 16 is 10. Okay? So, we know that it's going to be this pair, 6 and 16. We need to choose which one of those numbers will have to be negative in order for it to add to give you positive 10. Right? So all of us should be thinking of that right now, or should already know that that negative 6 will have to be negative there. Okay. So now that we've got these two factors, the negative 6 and the 16, what we want to do is we want to use those two factors to split the middle term. And what we mean by that is we're going to replace the middle term with two separate terms that are technically still equivalent with that original linear term. You know, the term that has x to the first power in it. So again, we see here that after we had chosen those two factors, negative 6 and positive 16, what we did was we split up that middle term, that term that had the linear variable where the exponent was 1, the 10x. We split up that term using those two factors, negative 6 and 16. So again, we rewrote the original expression, and we replaced that middle term with these two terms. So again, you can see that the 10x has been split, but that these two terms there that it's been replaced with are technically still equivalent to the 10x. Again, if you had to go backwards now and combine these two like terms, we would see that they are indeed equivalent to 10x. Alright, so now that we've got it written with 4 terms, what we want to do is now we can actually factor by grouping. So that's what we're going to do. In that last video that we that I made, we showed you this, or I showed you the steps for factoring by grouping, where first you have to group the first two terms and the last two terms using parentheses. Next, you have to take out the GCFs from both of those groups. Then, once you've taken out the GCFs, you should notice and you should recognize that there's the same factor left over from each of those groups. And so if you notice that there's the same factor left over, that's when you can write out your final two factors. So one factor is going to come from the GCFs, where you put those GCFs together as one factor, and the other factor is going to be that same factor that we had. But again, we'll walk through that in just a sec. So now that we are ready to factor by grouping, remember that again, if you've already got the expression written with 4 terms, the first thing that you do is you group the first two terms with parentheses and the last two terms with parentheses. Okay, so we've grouped the terms with parentheses. Next, we factor out both of the GCFs, and so that means that we identify the GCF of the first group and of the second group. From that first group, the GCF would be 3x. And from the second group, the GCF would wind up being 16. And so when we factor out those two GCFs and we put those on the outside of the parentheses, we have 3x times x minus 2 left over. And then for the other one, we'd have 16 on the outside. And what's left over would be x minus 2. Again, once you've got those GCFs factored out, you will notice that there are that we have the same factor shows up, the x minus 2, and you see that it's repeating, x minus 2, x minus 2. So again, after you realize that again that you've got that same factor, what you want to do is actually write out your final factors. You're going to use the GCFs that were already there. You're going to use that GCFs. So the 3x and the 16, that's going to be a part of one factor, and then the other factor is going to have x minus 2 in it. So our final answer will wind up looking like this here. 3x plus 16 times x minus 2. Again, one of those factors is the GCFs, which is 3x plus 16, and the other factor is that same factor that was revealed after we took out or factored out the GCFs. I think I'm going to do one more example here very quickly, and I'm pretty sure that I won't write out all of the steps that I just did. So yeah, we'll look at another example. Okay, so let's work this out here. So if we're going to factor this by grouping, we know that the first step is after we've identified your A, B, and C. A is -4, B is -11, and C is 20, that we multiply A times C, and we have to find factors of that number. So again, we multiply A times C here. Okay, so that's AC. So we find A times C is equal to -80. Alright, and we find factors of -80 that are going to add to give you -11. Because again, we find factors of A times C, or factors of the product AC, that are adding to -11. Alright, and so if you can't think of those factors in your head, factors of -80, then you may want to write it down. Write down those factors. Eesh, that is just so sloppy, guys. Alright, so if we write down factors of 80 here, factors of -80, and try to figure out which ones will add to give you -11. Right now, I'm just going to write the factors. Okay, factors of 80 are 1 and 80, 2 and 40, 4 and 20, 5 and 16, 8 and 10. So again, we're looking for two factors here that multiply to give you negative 80, but that add to give you negative 11. So again, since this is a negative number, remember we're looking for one of these factors to be negative. So when we look at the difference between all of these, the only pair here of factors that will give us a difference of 11 is 5 and 16. So the question is, which one of those two, 5 or 16, will be negative so that it adds to give you negative 11? And of course here the answer is that negative 16. 16 will be the one that's negative there, so that it adds to the right thing. Alright, so we know that it's these two, and so whether we draw out the little x factor or not, that's fine. We know that it's these two factors. So remember, next we use those two factors to split up our middle term, so that we can have this written as a polynomial with 4 terms. So that'll be negative 4x squared plus 5x minus 16x plus 20. So now that it's written with 4 terms, we can factor by grouping. Remember that when we are factoring by grouping, what we do is first we group our terms, group the first 2 terms together and group the last 2 terms together. And what I'm going to make mention of here before I actually do that is the little ratio. Okay, so in the first video that I made about factoring by grouping, I had mentioned that in order for us to be able to factor by grouping, we need for the ratio of our coefficients, the ratio of the first 2 coefficients needs to match the ratio of the second 2 coefficients. So that ratio here is negative 4 to 5, and the ratio for the last 2 coefficients is negative 16 to 20. Technically, these match. However, let me just kind of state something here. Whenever we are, okay, let's try this again. Whenever we are looking at these coefficients, if the signs for these do not match up, so again, notice how the sign is a negative for this first one, but a positive for, so it's a negative 4, a positive 5, right? So this is a negative and then a positive, right? A negative and then a positive. But notice how the signs don't match in the other one. How that's negative and then positive. So see how the signs don't match? Even though technically it's still equivalent because they're both equal to, if they were written out as a fraction, they're both equal to negative 0.8 or negative 4/5. So they're equivalent, and we can factor by grouping, but I just want to point out that again, those signs are not the same. Whenever you have the fact that that these signs on the left side are opposite of the signs that are on the right side for these pairs. So whenever they're opposite like that, we are going to, when we factor out a GCF, we're going to have to factor out a negative for one set, or we're going to have to factor out a negative number for one group. Okay, so guys, I have switched these 2 middle terms, and so these parts that I now have written in green, I've switched those 2 middle terms because there's a certain point that I'm trying to make here about what happens when your two ratios are equivalent but your signs don't match up. And so I've put the negative 16x first and the 5x second. And so with that, the ratios still match. Okay, with the negative 16 coming first and then the 5 coming second in the second group, the ratios still match up as being 0.25. But again, here are your signs. So the two signs on the left for the first group are both negative. But notice how the two signs on the right now for the second group are both positive. So again, your signs on the left for that first group do not match with the signs on the right. Okay? So you have completely different and opposite signs. When that happens, folks, and when you do have opposite signs like this, you will have to factor out a negative number for one of those groups. So when we factor out those GCFs, and again, one of those factors, one of those GCFs is negative. Again, and one of the GCFs has to be negative because the signs for the ratios don't match. The two signs on the left side are the opposite of the two signs on the right side. Okay. Alright, and so when we do that and factor out those GCFs, negative 4x on the outside, and what's left over other than x plus 4, and then putting the 5 out, taking out the 5 as a common factor, we've got x plus 4 left over. So again, here we can see that we've got the same common factor, x plus 4, and we've got the GCFs, negative 4x and 5. So remember, when we're if we notice that we've got that same factor, we're on the right track, and we can write out our final factors. Again, one of the factors is going to be the GCFs, and the other factor is going to be that same factor there. So again, folks, we have completely factored this quadratic trinomial where the a was not equal to 1, and we did that factoring by grouping. I do hope that this video was helpful to you guys. Again, this was part 2 of a series on factoring by grouping. That's it.